Hi guys, my name is Pearl and we're going to be solving this question. So basically the question wants us to calculate the coefficient of friction between the ladder and the floor. So first of all, you need to know the formula that contains coefficient of friction. It is frictional force equals to coefficient of friction times reaction. I'm using the variables that are used here, that's all. The reaction in this case is the vertical force. You can see it's going up in this direction, and they gave us two downward forces. The man's weight, that's 750, and the weight of the ladder itself, 900 newtons. In order to resolve these vertical forces to obtain the total vertical force, we can just say sum of downward forces is equals to sum of upward forces. This is basic Newton law. Equals to the total is equal to 160 newton. So you can simply say RF is now equals to 1650 newtons, and the frictional force FF is going to be 1650 times coefficient of friction. In order to start resolving the forces in this particular order, you have to understand that this is a question about moment. We're going to take the moment as point B. I'm purposely choosing point B and not point A because if it's point A, it introduces a new unknown variable. I'll show you as we solve. So we're going to take the moment at B. Now, you know from moment, you see the clockwise moment produced at the pivot point must be equals to the anti-clockwise moment. So now first let's find our clockwise moment. The first clockwise moment is actually going to be reaction force. Clockwise moment means it's going to create a turning anti-clockwise effect at point B. And let me just show you that. So if the ladder is at this point and there's a force acting this way, if you keep pushing the ladder upwards, guess what? It begins to turn in this direction. It keeps going down as you keep pushing this point up. So it's going to create a clockwise moment. So therefore, we know moment is force times distance. I forgot to write this. The force in that case is Rf, which we now know as 1650 newtons, times the perpendicular distance. Now this one is going to be a bit tricky, so let me show you. We're going to draw it out. You see, this is B to C. This is A. I'm going to draw it as a box. I'm basically taking something like this from this point. This is A to B. The frictional force is in this direction. It is stopping the ladder from sliding. The ladder is trying to slide in this direction, but the frictional force is always opposing the motion, so it's acting in this direction. It's even shown in the diagram. Next, the direction force is in this direction. Now, perpendicular force is angle 70 degrees, and this is angle 20 degrees by right angle triangle law. The perpendicular distance of RF from the pivot point B is simply going to be from here to this point. So just keep in mind that if your force is vertical, the vertical distance, the perpendicular distance will be measured along the horizontal line. If it is horizontal, the force is horizontal, then the perpendicular distance will be measured vertically. So just keep that in mind whenever you're solving count questions. So from here to this point, we know that this entire length is 5 meters. It's going to be 5 sine 20. So you're just going to write 5 sine 20 here. Now equals to, there's no other clockwise moment that's going to happen here. So now equals to the anti-clockwise moment for this. The first anti-clockwise moment is actually the frictional force. You see, the frictional force, I'm just going to erase this. You see, the frictional force is pulling the ladder in, therefore it's taking B anti-clockwise direction, is pushing it in, causing B to push out. So you can just imagine it, just think about it. So you're going to have the force, frictional force, which is now 160 50, 160 50. Hey, 1650 times the coefficient of friction. Then its horizontal distance is, then its perpendicular distance is simply going to be measured from this point to this point. Remember what I said? It's going to be 5 cos 20 degrees. It's going to be times 5 cos 20 degrees. Next, we're going to be adding the next anti-clockwise moment we see. The next one is going to be from this 90 newtons here. So this one, to know the kind of moment is the kind of turning effect is creating is if you're standing on a ladder in this direction, and God forbid, let's just say here happens to break. Guess what's going to happen? This point of the ladder is going to bend in this direction, in the what? Anti-clockwise direction. So that's how I think about it. If you want to understand what's the turning force this particular force creates at the pivot, you just think about it as a hinge. If this point was a hinge, what direction would this turn to? So that's just it. So it's an anti-clockwise moment. So you're simply now going to just write out the solution. The force is 900 newtons. And then to get the perpendicular distance, we have to draw it out a bit. So this is I'm just drawing at this point. The 90 newtons is at this 900 newtons at this point. The angle at this point, if this is 70, here will be 90, therefore here must be 20 degrees. Next, this is the point B. From this point to this point is actually going to be 2.5 because it's half of the ladder. Now, like I said, if the force is vertical, that means the perpendicular distance will be measured horizontally. So the perpendicular distance is from this point to this point. Using Sokata, you can see tell that this portion will be 2.5 sine 20 degrees. So times sine 20 degrees. Next, the last one is the 750 newtons. It's also producing an anti-clockwise moment. Just imagine if the ladder broke at that point, where would B turn to? So in that case, if I'm just so easy, just change 500, 750 newton. This point is going to be from here to here is actually going to be 5 minus 1.5. That's 3.5 meters. So it's just going to be 3.5 sine 20. 3.5 sine 20. Yes, this is going to be the answer. So let's simplify. Simply going to come 2821.7 equals to 1650. Coefficient of friction times 5 cos 20 degrees plus 106.67.3. Simply move this to the left hand side, and honestly I feel like we can simplify it easily from here. You're going to have that the coefficient of friction is equals to 2000, this minus this. So that will just simply be 1154.4. 5 cos 2.0 is simply 4.6985 and is multiplying with 106.50. So our final answer will be 0.149, which can approximate to 0.15. So this is actually our final answer. Thank you for listening. Anything you do not understand, do not hesitate to ask in the comment section. Thank you.